In this video, we're going to look at solving trig equations that involve factoring. So before we looked at just simple trig equations that had one function, sine, cosine, or tangent, and then some constants. So here we'll have some that have squared terms in them, so quadratic terms, or perhaps two different functions in them. So we're going to start with this one, which is just a quadratic. So notice you have two sines squared, so you have a quadratic and a trig. So what we're going to want to do is sort of combine our procedures for quadratics, which means set everything equal to 0, and use our trig procedures as well. So I'm going to start by just putting all the terms on one side of the equation here. So 2 sine squared x minus 3 sine x minus 1 equals 0. Now we can either factor this or we could use the quadratic formula to solve. In this particular case, this one does not factor easily, so I'm going to use the quadratic formula, or I can use my calculator and I can use my quad program. So if I just do the quad program, I'm going to go 2, -3, and -1. Then from my quad program, I get the 1.78 and the -0.28. So then we're going to say sine of x. So my quadratic term is not just x, it's sine of x. So we have to do sine of x equals 1.78 and sine of x equals -0.28. Now I want to go back to my trig procedure. So now here for each of these I'm going to do period is just going to be 2 pi divided by 1 here, and then the same over here, period is 2 pi. Now I can start solving the trig equation. So this is going to be x equals inverse sine of 1.78. This is going to be x's inverse sine of -0.28. So using my calculator, this part's going to give me no solution. So I can just kind of stop with that side, and over here I'm going to get about -0.28. Then I have to find my second solution over here, so I have to do x equals 1/2 of my period, which is 2 pi, minus -0.28, which is going to give me about 3.42. The directions asked for solutions between 0 and 2 pi. So my first solution, -0.28, is not between 0 and 2 pi. So remember, if I have a solution that's not in the range that I need, I can add or subtract the period to get a solution that might be in that range. So I'm going to do -0.28 plus 2 pi, which is going to give me about 6.00. So 6.00 is between 0 and 2 pi, 3.42 is between 0 and 2 pi. So those would be my two solutions. So this x is 3.42 and x is 6.00. I could also solve this equation by graphing on my calculator. So I'm going to come to my calculator. I'm still going to move everything to one side and set it equal to 0 just because it's a little bit easier that way. So I'm going to do 2 sine squared. Make sure you close the parenthesis on the x before you put the squared on it, which I know is different than the way we write it, but in your calculator that's how you have to do it. Minus 3 sine of x, and then I'm going to bring the 1 over. So -1, and then the other side of the equation will just be 0, so it'll look similar to what we have written here in the black. Then I'm going to go to my window because they gave me a specific range of x values, so I went between 0 and 2 pi. Looks like I have that. And then I'm just going to graph. From the graph we can see the two intersection points, and then we can do second trace intersection. So I get my first solution, which is the 3.43 about here, and then second trace intersection we get about 5.99. So we're slightly off between the calculator graphing solutions and these solutions, and it's probably because we rounded these 0.28 and 1.78 from the beginning, but it's perfectly fine and acceptable answers. Alright, so here's a similar question. This one says solve between -2 pi and 2 pi, so we're looking for a little bit wider of a range of solutions here. And here we have sine x minus cosine squared x equals 1. So we see the squared in there, so that tells me I'm going to have to do a little bit of factoring. Also notice that this is sine x and cosine x. So we can't factor or use the quadratic program until both of the functions are the same. So what I'm going to do first here is I'm going to Bring the 1 over to the other side, first of all, minus cosine squared x minus 1 equals 0. So I've got everything on one side set equal to 0. Then remember, I have to do something so that I only have one function in there, either sine x or cosine x. With the squared on it, that's fine, but I can't have two different trig functions in there. So I'm going to think about my formula sheet, and I'm going to remember that the Pythagorean theorem says sine squared of theta plus cosine squared of theta equals 1. So if I get cosine squared theta by itself, cosine squared theta equals 1 minus sine squared theta. So I'm basically using the Pythagorean identity, and then I'm going to replace cosine squared x with 1 minus sine squared x. So I'm going to rewrite this sine of x minus, and then instead of the cosine squared x, remember we're going to write 1 minus sine squared x. I like to use the parentheses because in this case I'm going to have to distribute that negative, so it helps me remember that. So now I'm going to go ahead and distribute that negative. So I'm going to get minus 1 plus sine squared x minus 1 equals 0. So now I'm just going to write this into the standard form. So squared term first, and then my linear term. And then I'm going to combine my constants together, so I get minus 2 equals 0. So now I have a quadratic in standard form set equal to 0. So now remember, at this point I can factor, or I can use my quadratic program in my calculator, or I could do the quadratic program by hand. Sine x plus 2 sine x minus 1 equals 0. And then setting each of these equal to 0, I would get sine x plus 2 equals 0. So sine x equals negative 2. And over here I would get sine x minus 1 equals 0. So sine of x equals 1. Now remember, I could get straight from here to here by either doing the quadratic formula by hand or using my quad program in my calculator. So here we would just put in 1, 1, and negative 2, and I get the same answers there. So either way, doesn't matter. Now I'm going to use my trig procedures, which remember tells me that each of these I'm going to find the period. So period of each of these is just 2 pi because my coefficient on x is just 1. And I'm going to solve, so this is going to give me x's inverse sine of negative 2. Hopefully by this point you know, since your argument there is not between negative 1 and positive 1, this is going to give you no solution. If you put that in your calculator and got no solution that way, that's fine. Over here I'm going to get x's inverse sine of 1. I can put that into my calculator, or if I use my circle, I would get x equals pi over 2. And then remember, we have to find the second solution here. So x is going to be 1/2 of my period, which is 2 pi, minus pi over 2, which is going to also give me pi over 2. So I really just end up with one solution, which is x equals pi over 2. Here we've got the x equals pi over 2. Which is basically my solution within one period, which is from 0 to 2 pi. So remember, I want to go back as well. So if we just kind of think of a number line, we've got 0 here, we've got 2 pi. They asked us to find solutions back to negative 2 pi. So I've got this solution here, which is pi over 2. Remember, I can find any other solution by adding or subtracting the period. So if I subtract the period, come back and I'll end up over here. So if we do pi over 2 minus 2 pi, that will give us pi over 2 minus 4 pi over 2, which will give us negative 3 pi over 2. So my solutions in the range they asked for are x equals pi over 2 and negative 3 pi over 2. So if I come to my calculator, I'm going to put this equation in. Again, I'm going to move the 1 over to the other side. I'm not going to replace anything, though, like I did with the algebraic method. So I'm just going to go sine x minus cosine squared x. So remember, in my calculator, I have to type it in cosine x and then squared outside the parentheses. And then I'm going to bring over the minus 1. I'm going to go to my window. Notice this time they said they wanted solutions from negative 2 pi to 2 pi. So I'm going to put in negative 2 pi here. And then this is 2 pi here. So then I can go ahead and graph that. So now I can see actually that I have two solutions. The second trace intersection gives me the 1.57, which is pi over 2. We can also come back over here, and here we get our negative solution.